Hi everyone, this is another peaceful day, and welcome to the world of physics. Today, we are discussing about Dirac delta function. In 1880 the self-taught electrical scientist Oliver Heaviside introduced the following function, which is now called Heaviside step function, which is a discontinuous function, with a discontinuity of first kind at x equals 0, which is often used in the context of the analysis of electric signals. Moreover, it is important to stress that the Heaviside step function appears also in the context of quantum statistical physics. In fact, the Fermi-Dirac function, or Fermi-Dirac distribution, proposed in 1926 by Enrico Fermi and Paul Dirac to describe the quantum statistical distribution of electrons in metals. F beta of x equals 1 by e raised to beta x plus 1. It becomes the function f minus x in the limit of very small temperature T, namely, limit of n turns to infinity f beta of x equal to theta of minus x equal to 1 if x greater than 0, 0 if x less than 0. Inspired by the work of Heaviside, with the purpose of describing an extremely localized charge density, Paul Dirac investigated and imposing that integral minus infinity to plus infinity delta of x equals 1. Anyway, before we go into the question related to the delta function, we have to understand the properties of it. Delta of x is equal to delta of minus x. Derivative of delta of x is equal to negative derivative of delta of minus x. Integral minus infinity to plus infinity delta of x minus x naught dx is equal to 1. Integral from a to b delta of x minus x naught dx is equal to 1, if x naught lies in between a and b or equal to 0. Delta of a multiplied by x minus x naught dx is equal to 1 by mod delta of x minus x naught. Integral a to b f of x delta of x minus c dx is equal to f of c, if c lies in between a and b, otherwise it is 0. Now, Dirac delta of a function can be solved by 3 steps. First one is, put f of x as 0 and find the roots. Second step is to take derivative of the function and simplify the function by using the roots. And third step is delta of the function is equal to summation over I delta of x minus xi, divided by mod f dash xi. The integral minus infinity to plus infinity, f of x nth derivative of delta function dx can be calculated by transferring the derivative to the function, and multiply with minus 1 raised to n. Let us go to some related problem. Integral 0 to 2 pi cos x delta of x pi dx, which can be calculated by a sixth property. Integral a to b f of x delta of x minus c dx is equal to f of c, if c lies in between a and b, otherwise it is 0. That is, pi lies in between 0 and 2 pi, so that the answer will be cos pi, and which is equal to minus 1. Next question is integral 0 to 3, x cubed delta of x plus 1 dx, here the c is minus 1, and which is not lay in between the 0 and 3, so that the answer will be 0. Next question is integral minus infinity to plus infinity exponential of mod x delta of x dx, it includes a mode function, that is, mod x will be x when x is greater than 0 and it will be minus x when x less than 0, so, the integral part is split into 2, that is, integral minus infinity to 0 exponential minus x delta of x dx, plus integral 0 to infinity exponential x delta of x dx. Further, it's solved by the sixth property. Integral a to b f of x delta of x minus c dx is equal to f of c, if c lies in between a and b, otherwise it is 0. By putting the value of c equal to 0 in the function, we will get the result is equal to 2. Next question is, delta of x squared plus x minus 2. It can be solved by using seventh property. Now, Dirac delta of a function can be solved by 3 steps. First one is, put f of x as 0 and find the roots. Second step is to take derivative of the function and simplify the function by using the roots. By the first step, the roots of the function will be minus 2 and 1. And taking the derivative of the function and applying the roots we will get the f dash xi. Finally, the delta of x squared plus x minus 2 is equal to delta of x minus 1 divided by 3 minus delta of x plus 2. Next question, delta of cos x. By using the same property, root of the function will be plus or minus 2n plus 1 pi by 2, and the derivative of the function will be negative of sin x. And finally, the delta of cos x is equal to summation over n, delta of x plus or minus 2n plus 1 pi by 2, divided by modulus of derivative function. Now, we look into another problem included the derivative of delta function minus infinity to plus infinity x squared d by dx of delta of x, which is simplified by using the eighth property. The integral minus infinity to plus infinity, f of x nth derivative of delta function dx can be calculated by transferring the derivative to the function, and multiply with minus 1 raised to n. That is equal to minus 1 raised to 1, integral minus infinity to plus infinity d by dx of x squared delta of x dx. By solving the equation results, integral minus infinity to plus infinity x squared d by dx of delta of x dx, equal to 0. Next question is, integral minus infinity to plus infinity exponential of x alpha delta x plus beta delta dash x plus gamma delta double dash x dx. By using the eighth property, derivative of each delta function is transferred to the exponential function. Finally, the result is alpha plus beta ik minus k square gamma.